It's a Thursday. It's February 5th, 2026. When you or a loved one has suffered serious harm, look to Wyoming's board-certified truck accident lawyer Grant Lawson, leading the charge for accountability and fighting for safer roads. Don't settle for anything less. Visit truckaccidents.com. Yep, I hate to say it, guys. You know, the honey-do list, if you've got something to do outside that you've been putting off, you got no excuses. We're just going to have incredibly beautiful weather here over the next several days. And of course, you want to get it all done before Sunday, correct? And certainly the deer out there enjoying the beautiful blue skies there in Livermore, Colorado. That this photo reminded me of what we're experiencing this winter and maybe how it's affecting wildlife. Sure, the lack of moisture isn't good, but we don't have to go very far back to the winter of 2023 when the mule deer, the antelope, and the elk winter kill in many areas of the Intermountain West was through the roof because of the severe snow that winter. And look what's happened just 3 seasons later, the exact opposite. So if you want to pick one benefit of the mild winter so far, there may be a benefit there. Now, the Western Ridge, as I'll show you on the satellite imagery and as we've discussed, is just huge, just completely dominant. That's why the weather is going to be unbeatable. If you want to do something outdoors or travel, even the wind isn't going to blow very much. Now, the ridge is going to go away as the Pacific flow is going to punch down that high pressure ridge and put it to bed. It's going to be a process, but it's going to start to get weaker starting over the weekend, but it's going to hold through then. A rather disorganized area of colder, moist air and low pressure comes into the western United States. What we do not have next week is a cohesive, really strong, one organized storm. Rather, colder, moist air settling in. That colder, moist air will work with the mountains and other factors to bring a colder, unsettled weather pattern, and some precipitation is certainly coming into the western United States next week. Is it the big one? No, it is not the big one. But we will be looking at other potential for larger storms as the pattern stays favorable. This pattern change, confidence is very high that the pattern change is happening. Now the devil's in the details. And what is this pattern change actually going to produce? That's what we have to wait and see. Also, at the end of the podcast for you weather geeks, I'm going to do Tonga Talk. Want to talk about the Tonga volcanic eruption in January 22 and some of the scientific papers that are just now reaching the journals. And it really is looking like that Tonga eruption has had much bigger impacts in our real everyday weather globally than we thought it would. And there's some reasons for that, and we'll talk about that here at the end of the podcast. In the meantime, we have a lot of beautiful sunrise, sunset photos. Now that we're back to high pressure, we're back to fair weather cirrus clouds, but boy, it makes for a beautiful backdrop. As you can see, all across the Intermountain West and the western high plains, from the western slope to the Black Hills of South Dakota. And we'll probably have some skyscapes like this over the course of the next several evenings, and then more high-level cirrus clouds there across eastern Wyoming heading into western Nebraska. The satellite photo this morning is really quite remarkable to show you the strength of the ridge. When you see this, it is completely, just completely clear. Very, very few clouds under the sinking motion of the high pressure ridge. That's the thing with high pressure ridges. The general motion of the atmosphere is to sink. And if the air is sinking, you can't have any vertical motion to build clouds or precipitation. That's why when you get high pressure systems of this magnitude, and speaking of magnitude, when we look at the water vapor, this really shows you the sinking motion, because if the air sinks, it warms, the relative humidity drops, and the air becomes drier. That's why you have all that fair weather. And the orange here in the water vapor shows the real dryness, and this is the clockwise flow of the high pressure that you see, this little tongue pushing into Idaho here. So this is about as robust of a ridge pattern that you're going to get this time of year. So it's going to be completely dominant, and anything coming from the Pacific just hits it and goes up over and around. And of course, where does it go? It goes to our east, as has been the case. And the 500 millibar chart shows that very well. You see the low hitting the high, it's getting stretched. It's like, oh, I want to come through. The high says no. And that's going to be the case here through the course of the weekend. And of course, the trajectory of air is coming still out of Hudson Bay of central Canada into the eastern United States. So for the third weekend in a row, while the cold won't be as extensive, it's still going to be much colder than average in that part of the country. Then as we get into Sunday, so this is today, Sunday, see how the flow straightens out. So this is going to bring relief. This will bring a Pacific air mass and the warmer air that's building in the Rockies. It's going to start to send it east, and a lot of the country will start by the end of the weekend and early next week having a thaw. They finally get a break in the east. With the high pressure ridge going down, the colder moist air mass that I talked about that's going to be rather disorganized is going to start to have the availability to move. It's just not going to be blocked anymore. So between now and Sunday, this is what the precipitation pattern looks like. Look at this. Massive area of barely anything. We're going to get showers. There's that little upper low off the Baja here. You're going to get a little bit of shower activity over the Sierras and over northwest Mexico, even southern Arizona, but severe clear elsewhere through that whole period. So good weather for the Super Bowl on Sunday. So this takes us through Sunday. After Sunday, by Tuesday, we kind of have a fractured low. It's going to kind of come in two pieces. Up here, the air is a lot colder and it's pretty moist. It's not Arctic cold, it's North Pacific cold, but certainly colder. So the Washington and Oregon areas in Northern California by late Sunday into Monday, Tuesday are going to be getting wet. The warmer air spreads out of the Rockies there, but we're still, at least into Monday and Tuesday, going to be still pretty mild in the southwest flow ahead of this. But as we get into Wednesday and Thursday, it's disorganized, as I said, but we've got the colder air coming down the Rockies, filling into parts of the Great Basin, and we've got some moisture coming up from the southern latitudes coming through here. So the interaction between these two, so this is not going to be a four corners low. This is not, as I said, this isn't the big one. This is the start of the change. We see the strong jet stream winds coming in here behind it. So this is going to set the stage for this one to come through. You might say, well, here comes another high. See how the high is tilted to the right? A rightly tilted axis is an inherently unstable axis, so it can't maintain itself. So this will take over. So this is simple physics. This will not be able to build back into the west as long as it has that tilt like that. So it's not going to survive, as you'll see here in a moment. So when we look at where we're going to be by Tuesday morning, we should be seeing snow back into Jackson, maybe even the parts of Star Valley here, and into Boise, some rain and snow. Even eastern Washington and Oregon could have a little bit of precipitation, in the northern Sierras as well. That upper level low in Mexico, actually bringing some weather down there. But you see through Tuesday, we still have a lot of white, not a lot going on. Once we get beyond Tuesday into Wednesday and Thursday, the system, that disorganized, colder, moist air mass comes through. Now, these precipitation amounts are by no means extraordinary, but we're going from zero. So if you're going from zero, it means something. So we're starting to see a little bit of weather coming through, and it does look like parts of Wyoming are going to be susceptible to some snowfall. Probably in the late Tuesday, Wednesday, Thursday timeframe. Maybe South Dakota, we'll see. I'm not buying all of this yet. So we're talking about something a week away. As I tell you all the time, when I show you these maps, these are for entertainment purposes only, so to speak. Yes, this could happen. This is the general trend of what's going to be happening. And certainly as we get closer and closer, the more consistency we see in the models, the better the opportunity. So this is the beginning of the weather pattern change. So there is going to be some opportunities for snow. Like I said, not buying this yet, but I think all of this that you're seeing, certainly in the mountains, in areas that you're seeing here west of the divide, I think this is a foregone conclusion. It's what ends up coming out east of the divide and whether or not that develops or not. But certainly, look at this, the mountains of central and southwest Colorado, even parts of the Wasatch and Utah, the Sierras, the Yellowstone Plateau, the Bighorns. Okay, finally getting into something. Now let's go out a little bit further. And what I'm doing, instead of throwing the H's out and the L's out, this is a little bit easier to decipher. What I'm showing you is the 500 millibar anomaly, which means it's going to show you based on color. So it's a little bit easier way to describe what's going on. So let's fast forward to Valentine's Day Saturday. The system that comes through mid to late next week has the potential to cause a Valentine's Day storm along the East Coast. That's something that we've got to look for. Now, out west, we do have a little bit of high pressure that does slip in behind it that I showed you there as we get into late next week and the start of next weekend, although colder northwest flow comes into here. But here we have another low, and the big bright red here is the high that's building in behind it. This is the main high, so to speak. And so it's in a place where it's more favorable for this guy to head east and these guys up here to head like this. So for Valentine's weekend, watch out for a Midwest East Coast storm. Colder, moist air comes in behind it. So the weather stays cooler and still rather active, especially in the northern Rockies. Then when we go into Tuesday next week, look at this. So whether or not this happens, we'll just wait and see. But I will tell you this, all the major model suites are saying the same thing, which is we get the ridge here finally, and this opens up the west to a lot of blue and green. So you're going to see a deeper low here come together. If all of this transpires, you have the warming trend continue into the east. So this is the reversal. The stormy weather hits the west instead of the east. And we actually have a high pressure area here instead of a deep low over Hudson Bay. It's flipped. Again, a reversal from what's going on. And if we go 2 days later, we have a very consolidated storm that is kind of more like your Four Corners system around the 18th and 19th of February. And you see this in Alaska? Well, as long as this configuration holds, where the general high pressure is here, this low will then come in behind this one. So the rest of February does show signs of being a lot more busy than we've seen lately. Now I want to talk a little bit about the Tonga volcanic eruption. This happened, to review, in January of 2022. Tonga, the best, closest place I can give you as a point of reference would be near New Zealand, but pretty far out in the Pacific Ocean, the South Pacific Ocean, in the southern hemisphere, generally east of New Zealand. What was different about this volcanic eruption, and this is critically important to understand how it may be affecting our weather and climate patterns, is that it was an underwater volcano where the eruption, the main eruption, was far underwater. And the eruption was of such a magnitude, and this is hard to wrap your brain around, but it was such a magnitude that it put an estimate, and there's pretty good agreement across the journals, 1.5 trillion gallons of water was thrown into the atmosphere. Not just the atmosphere in a general sense, it went through the troposphere where we live and breathe. It went where the biggest volume of water ended up in the form of water vapor was the stratosphere, but it even reached the lower layers of the mesosphere. Now, you might say, well, it's just a volcanic eruption. No. Nothing of this magnitude in terms of a volcanic eruption has thrown this much water vapor into the higher layers of the atmosphere, especially the stratosphere, since we've had in the satellite era, which goes back to the late 1970s. We haven't witnessed anything of this magnitude in not only the satellite era, but we've got to go way, way back. And then by then we don't have satellites. We don't have anything to measure what's going on. So this is really important to point out. This volcanic eruption of this magnitude, of the amount of water put in the stratosphere, has never been observed, at least in the modern era. So we're going to be learning things. So when you have something like this happens, you might say, oh, a volcano goes off, this is going to happen. So if A happens, B happens. No, you can't do that in this situation. This was off the scales. And so this was a volcanic eruption that sent not one but two shock waves that you could measure on barometers across the entire globe. And you could see the huge explosion from satellite imagery. I mean, it was incredible. In fact, this should be a lot more of a story than it is. So this is one way to kind of quantify what 150 trillion gallons of water means. So basically, about 1.2 the amount of the water in Lake Erie was put into the high atmosphere, stratosphere, lower mesosphere, parts of the troposphere. So that's one way to understand it. Now this graph here at the bottom is really, really important to show you. This is why having all the satellites and everything else so we can measure things. Again, measuring things is so important. But here are years. You can see where the Tonga eruption happened. And what we're trying to show you here is the amount of water vapor at 10 millibars, basically. So we're talking very, very high. Where I show you the stratospheric warming events, I show those to you at 10 millibars. So we're talking very, very high in the stratosphere. So the water vapor is shown in green here. So you can actually see what happened. Now you might say, well, that eruption was in the southern hemisphere. That doesn't affect us because it's going to stay south of the equator. No. This graphic shows it very well. Look at the dispersal, because anything north of this 0 is in the northern hemisphere. This is the southern hemisphere here. The amount of water vapor that spread into both hemispheres starting in January 2022, and you can see the gradient. You see that right after the eruption through 23 into early 24 was the highest water content. And since then, it's thinned out a little bit. However, point of reference, it's solid green here. So if you look up here in the graphic, a 13% increase in global stratospheric water mass compared to the baseline. This is going to interrupt things. This is going to change things. And this is going to alter how weather patterns and climate patterns are going to behave. The big problem in atmospheric science and trying to forecast is if we haven't experienced anything like this before, we have nothing to understand what we should expect. And then, as I tell you all the time, it's never one thing, it's a combination of variables that work together or work against together. Then in all of these layers, you also have El Nino, you have La Nina, you have the QBO, you have the Pacific Decadal Oscillation, the Atlantic Meridional Oscillation. You have all these things that are in the background. And all of these things are doing their thing. Then you throw in this volcanic eruption, and this should be one of the biggest climate stories of the century so far. It's really not being reported on enough, unless you are watching the journals and that type of thing. Some of this might get into the news, but not very much of it. I took this from Ryan Maui, who is a private meteorologist down in the Georgia area, and he put together this graphic about kind of the timeline of what has happened since the eruption. And this timeline at the bottom is if the eruption had not occurred. Now keep in mind, at the beginning of the podcast, I talked about the big snow year of 2023 and all the winter kill. So we had a huge amount of that water vapor go into the atmosphere. The water vapor going into the stratosphere, the water vapor is the most potent greenhouse gas. Number one, nothing can beat the amount of what water vapor can do to affect things, temperature and a lot of other things. So if you think about a year after the eruption, we had the big snows in the west, okay? We also had circulation disruptions in the higher latitudes. Then we start to slowly lose the water vapor, as I showed you in the graph, but it's still there. Estimates are right now that it could be 10 years where that elevated water vapor in the higher altitudes, stratosphere, lower mesosphere, is probably going to affect things. Now this is where it gets really tricky, well, exactly how is that going to be impacting the weather? And are we going to be able to learn anything from this? Well, these are possibilities. Now keep in mind, these are in the scientific journals. A peer-reviewed paper does not mean it's the gospel truth, but people are coming out with ideas and they're putting the measurements to the test in terms of theories, in terms of, okay, after the eruption, these are just some of the basic things without going into the weeds on all the details. But the Tonga eruption may have very well interrupted the La Nina and El Nino cycle some, meaning we may have got an extra year of La Nina when we wouldn't have, for example. Okay, the very big snowpack years that we had in 2023, if you remember, we had so much snow, Lake Powell went up 8 feet. We had big atmospheric rivers that brought flooding to California. Remember, California just got a ton amount of rain and snow. This is when we had those giant snows in Tahoe, and we saw the big snowpack winter. There's, in all likelihood, again, it's never one thing. It's part of the puzzle. That's the thing I want you to remember here. Tonga may not have made that winter, but it was part of the equation. And that's how everything works with the weather. It's a combination of things, not one thing. Also, and I think this is maybe kind of a part of our winter so far here in the West and really globally, because it all depends on where you end up in the block. This stratospheric warming events may be influenced somewhat by Tonga, meaning we're getting more of them this year. I mean, they started in November of this year, and we hadn't seen that for over 40 years. We also are seeing them continuing, and probably are going to be seeing another one before the season's over. We have talked in multitudes this winter about the blocking patterns, about the block in the Aleutians and the block in Greenland. Those happen, they will happen, but they were off the charts strong. It is possible, again, this is out there in the journals, nothing is settled yet, but this is what they're looking at, is the possibility that the blocking pattern this year may have been influenced by the after effects of Tonga, which means our blocking pattern was on steroids. And it wouldn't have been on steroids. It would have been a more normal blocking pattern if we hadn't had the Tonga eruption. That's kind of the best way I can describe things. Since we don't have precedent for the Tonga eruption, it is very hard to know exactly all of the impacts of Tonga until after they happen, after we take measurements, after we try to start to model the impacts of what that volcano has done to all of the atmosphere, not just the troposphere, but high into the stratosphere and the lower mesosphere. So this is what makes weather forecasting and trying to understand climate dynamics so difficult. You can have an understanding and modeling of the atmosphere and take it forward in time. You throw in something of the magnitude of Tonga, everything's out the window. All your hard work on modeling the climate and the atmosphere can really be interrupted, something like this. So you can see this both ways. Trying to figure this out is going to be difficult, but it's also a significant learning opportunity, and maybe gives us a better understanding of what increased water vapor, sulfur dioxide, and those types of things do to the high stratosphere when you have a volcanic eruption of this magnitude. And as I mentioned earlier, the after effects could go up to a decade. It could take that long for the stratosphere to get back to its baseline. So I threw a lot at you there. More when I get it. Have yourself a good Thursday.